Not long ago, our entire game plan for getting back to the moon got thrown right out the window. Seriously, what we thought was a solid, decades-long strategy, well, it just vanished. But in its place, something way bigger, way bolder, is starting to take shape right on the lunar surface. So let's get into it and break down what this massive shift really means for our future in space.
This really is the story of a huge, dramatic pivot, one that completely redefines America's ambitions for the moon and, believe it or not, sets the stage for our first permanent home on another world.
So, picture this. It's March of 2026. We're just weeks away from the historic launch of Artemis 2. And then, bam. NASA announces a complete overhaul of the entire Artemis program, all in the name of getting a permanent foothold on the moon, and fast.
The Lunar Gateway, you know, that orbiting space station we've been planning for years as a kind of pit stop, it's been canceled, gone. In its place, we have something way more ambitious, Project Ignition. And the goal here isn't to just orbit the moon, it's to build a permanent base on the moon.
And listen, this isn't just some idea on a whiteboard. We're talking about a $20 billion initiative that's already getting started. The goal? To have a permanent, self-sustaining human base near the moon's south pole, which is packed with resources, and to get it done by 2030.
Okay, so with this massive new goal on the books, the Artemis 2 mission, which just launched, suddenly becomes so much more than a simple test flight. It's now the critical first step in making Project Ignition a reality.
On April 1st, 2026, for the first time since all the way back in 1972, humans launched toward the moon. Think about that for a second. This 10-day trip is the absolute proving ground for the technology and for the crew that are going to build our future out there.
And the mission started with a launch that was just picture perfect. At T-minus 30 seconds, the computers took over. Then at 6.6 seconds, those main engines came alive. And at T0, the solid rocket boosters lit up, pushing the crew to orbit with a flawless engine cutoff just 8 minutes later.
The power here is just staggering. The Space Launch System, the SLS rocket, kicked out over 8.8 million pounds of thrust. That's more than enough muscle to send the Orion capsule and its 4 astronauts on their journey all the way around the moon.
But here's the thing. This mission is about so much more than just raw power. It's a super high-stakes test of skill, of pure precision. It's all about proving these astronauts aren't just along for the ride. They are masters of this incredible new spacecraft. One of the most important things they had to do is something called proximity operations, or proxops for short. This is an absolutely essential skill you need if you're going to build a base. You know, docking with landers, assembling equipment, all that tricky stuff in deep space.
So here's how it worked. After Orion separated from the used-up rocket stage, the crew actually took manual control. They flipped the 25-ton capsule around and flew it right back toward the stage, getting as close as 9 meters. It's basically a test drive in space, right? They're just checking out how the ship handles, practicing the delicate moves they'll need for future missions. And you know what? The feedback from the pilot, Victor Glover, was exactly what everyone back on Earth wanted to hear. He said the Orion craft was precise, it was responsive, a huge checkmark that proves this vehicle is ready for the really complex work ahead.
All right, so the ship works, the crew can fly it. What's next? Let's take a look at the actual blueprint for Project Ignition and see how we get from this one test flight to a permanent home on the moon.
It's all going to happen in 3 main phases. First up is build, test, learn. That's where a whole fleet of robotic commercial landers will show up first to set up and test the power and comm systems. Then, in Phase 2, the first astronauts will arrive for shorter stays, using temporary habitats. And finally, Phase 3, that's when the big guns arrive, heavy lift landers delivering huge, permanent habitats and even a nuclear power station.
And what's so cool is that NASA isn't doing this alone. No way. This is a global effort. Japan is building an incredible pressurized rover. Italy is handling habitation modules. Canada is contributing a utility vehicle. And Europe is making sure all the vital communication links are solid. This is truly a planetary mission.
And that really gets to the heart of it all. It's a fundamental shift in how we think about space. Project Ignition isn't about planting a flag, taking a photo, and leaving. It's about building a home. Humanity is going to the moon. To stay.
But why, right? Why does building this multi-billion-dollar base on the moon matter so much? Well, as it turns out, the real answer is much, much farther away from home. See, the moon base isn't the final destination. As NASA officials keep saying, it's the ultimate proving ground. It's our testbed, our training camp for all the technologies and survival skills we are absolutely going to need for that next giant leap in exploration.
It's on the moon that we're going to figure out how to build things from the local soil, how to pull water from ice, how to shield ourselves from nasty deep space radiation. Every single challenge we solve in the lunar dust is basically a dress rehearsal for putting the first human boot prints on the red soil of Mars.
So in the end, Project Ignition is so much more than a construction project. It's a powerful statement about where we're headed. It's taking science fiction and turning it into a real engineering plan. It's setting the stage for humanity's next chapter out there in the cosmos. And it leaves us with a really powerful question. Once we have a permanent home on the moon, what's the next impossible thing we can achieve together?